All right. Good morning. What is up? C. Grover, nice to see you, my friend. Let's see. Here be. Heard a strange sound. To investigate for just a second. Let's see here. All right. I think I am about ready. Sorry, I know I'm a bit behind here. I was looking for some parts for stuff and strike a time this morning. Here we go. Oh, that's probably up the chat. Okay. Welcome for anyone who is new or watching this in the future. If you don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord. I usually stream around this time each week, 10 a.m. on Saturdays here on my channel, working on stuff related to CircuitPython. If you don't know what CircuitPython is, you can learn more about it at the website, the main website for the project here, circuitpython.org. It is basically a version of Python that runs on tiny computers called microcontrollers. You can see pictures of some of those here. We can also up the camera and see one of them here, a feather, reverse TFT S3 feather in this case. These are devices, typically though, if you use CircuitPython with them, the way it works, you plug it into your computer with a USB cable, it will show up like a thumb drive. You can edit a Python code file on that thumb drive. When you save it, the microcontroller will execute that Python code for you. So it will sort of run whatever is in that Python code, and then the code itself can interface with whatever other hardware you have hooked up. So these top row of devices are Raspberry Pi Picos. They're very general. They don't really have a lot of built-in hardware. They have a couple bits and bobs and a single button for the boot access, but all these things are mostly passive. There's nothing super duper interesting as far as like sensors or outputs or inputs or anything like that. The Picos excel because they have a bunch of pins. You can hook up whatever other stuff you want. Other things like this playground, they have more sort of stuff built in. So there's more buttons, in this case, a couple of user controllable buttons, a switch that you can make use of in your Python code, a speaker, a microphone, a bunch of neopixels. This one has an accelerometer as well, so you can do XYZ axis stuff, you know, control the VR mode or something of a headset or you know, what have you. So some of these devices have more or less stuff built in. All of the 651 here support CircuitPython, which is generally what I work on. C. Grover says, just wrapped up filming scenes this week. Nice. Of these sci-fi movie props I built. All were powered by CircuitPython, of course. We'll be sharing details when the movie is released. Yeah, that is awesome. I love to see all of the stuff that you have worked on, for sure. I know the last one was super cool. So I will look forward to that. So I am starting, well, let's say also thanks to Adafruit. Adafruit is a hardware and software company based out of New York. They make lots of microcontrollers that support CircuitPython, and they make the CircuitPython project possible by paying a team of folks like me to work on it. They also fund other open source software that is unrelated to CircuitPython, Arduino libraries, and more. If you would like to help support CircuitPython and the rest of the open source software work that they fund, one of the easiest ways to do it is purchase hardware from them at their website, adafruit.com. You can get microcontrollers, such as the reverse TFT that I have hooked up here, as well as this Perma Proto breadboard that it's connected to, in fact, and lots of the other stuff that's here in the background as well. You can also get little doodads, sensors, beepers, buzzers, RGB lights, all kinds of things that you can hook up to your microcontroller to do interesting and fun things with. Background IR remote queue control using async IO is essential. Nice. Okay, so you can control there. Nice. They can kind of on demand make it do whatever they need for the scene. Okay. It's the yeah. So jumping into what I would like to work on starts with Adafruit IO. Let me get logged into that. But I think I remember this off the top of my head, so let's. Okay. So for anyone who doesn't know, Adafruit IO is like a way to kind of give yourself a server backend without having to set up, well, not so much without having to set up, but without having to manage it down at the Linux server level. Gives you the ability to do lots of common sort of data storage, notifications via MQTT, sort of commonly used IoT based sort of server functionalities that you can use a handful of for free, like you can see the limits there, or you can sign up for higher limits. Well, like it mentions here. What's this? I don't know. There we go. Okay. And my aim, let me open up a few more things we're going to need. Actually, let's just a bunch of tabs here at once because they're all going to become useful. CircuitPython, we want the Adafruit IO library. We want get into sensors at some point. This one. $280. Probably don't need the page for that. Okay. To start with, though, let's get the link working, and I'll kind of explain what I'm after as I do that. Oh yeah, it's doing a weird thing that I left on there. That's fine. Maybe we can. I don't know if it will actually. Anyway, we don't really care what's on the screen right now. We will eventually get into drawing some different stuff on the screen, but for now that's fine. I will get Adafruit IO. Do not remember. This is an interesting choice. I think for now we're going to want this. I think we're going to want some HTTP as well here in a little while. Yeah, this will work as a good start. So this was some kind of JWT QR. In fact, I actually already saved it as another thing over here. Yeah. I think I need to keep that. I probably, 1 second here. Okay, interesting. Quite what I was expecting to find there, but it's not what I need either. In fact, I still need to do this over here. So I need to grab a settings.toml file. Obviously, I don't want to share that if I can avoid it. You'd need Adafruit IO stuff in here, which this one has. I'm gonna do this real fast, which I started doing in this file, which is a bunch of commented lines so that if I accidentally open it on the stream, it doesn't actually show anything. Unless I leave it scrolled down accidentally. All right, hopefully that token's still good. Oh, 1 second. I'm not sure these keys are right. Sorry, 1 more second, then we're coming back. Yeah, I was missing the Adafruit. I have only... I think this is just a change we made at some point in the examples. Okay, here we go. Now we're back. And this is wanting to hook up to demo feed. Received a new value. So right now I don't care as much about publishing from the microcontroller. I mostly just want to receive messages, and those messages are going to be on a particular feed, or right? What happens in on connect? Okay, connect. Here we go. Okay, this is the flow where I was lost a little bit. Okay, so connect. After you get connected, this callback gets called, and it calls subscribe to demo feed. Okay. So I would like to call this for now task queue. Probably change the name at some point. To feeds up here. Okay. So this should listen for us. Unable to connect. So one thing is, does this, it does try to connect here, but it didn't say that stuff, so it was maybe already connected? Connection refused, unauthorized. I'm guessing that that token was not valid anymore, so let me... Yeah, definitely not. One more time here. The downside of doing something like this that requires a token. Okay, here we go. So this has subscribed. Theoretically, I could put some data here, like a JSON object that says messages, which is a list, which has more things inside of it, which are like whatever for now. Let's just say message hello world. And I can create this, and theoretically over here, okay, we received this here. So whenever new data goes into this feed, as long as this script is running, it will receive the data here. It's JSON, so it can parse it back out and do more fun stuff with it. So that is like the backbone we need. So to get into more about what I'm actually aiming for, I will open this thing up and scroll up. This is a paper, like a research paper type thing, I guess, by this person, Olivia Zhu, co-authored, I guess. They refer to it as a collaborator with Claude Opus 4.6 and 4.7, which I will say definitely some parts of it show. But it's an interesting idea, and it's a thing that I'm going to work on sort of an Adafruit kit project version of. And I'll leave the abstract on here while I'm talking. If you want, you could pause and not listen to me and read it in their own words. But I'll give you the quick version as I perceive it and as I want to build it in this new project that I'm working on, which is basically a sort of like sidecar device that you could run on your network, or in this case, they actually use a bridge through the internet, which I suppose we are as well, right? Adafruit.io is on the internet. So this device sits on a network. It could be the same network as a different computer, or it could be a different one. And that other computer is running an LLM agent program. So like Claude Code or one of the many similar agent programs, OpenClaw, and all of the things that it spawned that are similar. And the LLM agent will be able to send a message through this bridge to the microcontroller that can say, like, give me back the sensor readings. So there can be sensors plugged into the microcontroller, of course. The LLM can ask for sensor readings, can get those back through the bridge. The other things that it can do are, it has some outputs as well. So like a vibration motor, we'll have neopixels on ours. The original, I don't think, did. There's a display, which we'll also have on ours, of course, because the TFT feather there has a display. And we may still switch up the device as well. This is early days too, so I'm very much tinkering and toying here just to feel out, you know, where the project is going to go. There's a display, so it can output like a face. There is a vibration motor, I think I said. There's a speaker, like a little piezo buzzer. And one of the core concepts of what the paper is about is this like self-perception loop. So for the vibration motor, there is also a accelerometer that is right next to it, essentially. And so when it vibrates, the accelerometer can tell that it did vibrate. And another one for the beeper, the piezo buzzer, there's a little microphone input that's right next to it that can measure the decibel levels. So it essentially can hear, it can know that the piezo buzzer made sound, or it can know that something made sound after it tries to activate the piezo buzzer, and it can infer probably that it was the piezo buzzer that did it. And so it's like this perception feedback loop of like, the LLM can decide to send an output to the world, buzz the motor or make a beep on the piezo beeper. And it can also sort of read the consequences of that action. It can confirm that that action took place with the accelerometer for the buzzer, with the speaker for the beeper. And then we are planning on adding neopixels and a lux sensor. So they talk about a lux sensor. They talk about this idea in the paper, but it was something they didn't implement in their version. But neopixels and a lux sensor gives it a third way to output something into the physical world, and then another one of those perception loops. It can have the lux sensor where the neopixels line up with it, so it can measure the output of that. Maybe even like a color sensor as well, so that it could tell the colors that the neopixels are on. We just worked on I don't remember the name of it, honestly, but we just worked on a couple of those color sensors that could do 14 color segments or whatever, had a bunch of different color things all built into one. So that is the very, very high level idea. And what I am, the very, very small chunk of it that I am trying to tackle today, or not even tackle so much as just feel my way through and sort of start thinking about, is the way that this bridge will work over Adafruit IO. So in this original paper, the bridge is a Node.js server. The client, the LLM client, sends requests to the Node server. The microcontroller also sends requests to the Node server. One or both of them long poll, so that it's sort of like a real-time message thing, sort of how the MQTT is going to act for us. I forget the exact... It wasn't... I thought there was a section which laid out a different way to... Yeah, I mean, this is pretty much this is what the chunk I want to look at today. So their bridge server is this Node.js server. My intention is not to use a Node.js server, but instead to use Adafruit IO as the backend for this. There will be things that will have to adapt, but essentially what we'll have is the microcontroller interacting with Adafruit IO and the agent client code interacting with Adafruit IO. And there's also no reason that you have to hook this up to an LLM agent either, right? Like on the microcontroller side, it's just like a command system for MQTT. You could use it for other stuff. Like if you want to integrate these sensors into some other system, it doesn't have to be driven by an LLM either. No, don't want to buy any user viewers. User viewers? Don't want to buy any viewers. Where's the ban button? It is here. All right, close this now. Yeah, so it's got this like FIFO queue of commands. We're gonna basically set this very similar kind of thing up, but we'll be storing the JSON in that IO feed that I just created. Yeah, so this one on the microcontroller, it sends a post every 10 seconds. So it uploads new sensor readings every 10 seconds. We may or may not do the same. I'm not sure. We'll have to see once we get into it. They did a lot of measurements and stuff. I don't care so much about how many milliseconds it took. Yeah, there's not much more about the network there. Wire protocol, HTTPS. Okay, yeah, they did this thing to cache bust browsers. Echo on true. So this is like that key to the perception loop thing. So on the piezo buzzer, when you want to not when the client side, so the LLM or whatever is controlling it, wants to beep and also perceive the beep, then what they'll do is they'll add this wait echo. This is like the cue that tells it, like, not only do I want you to do this thing, but I want you to also try and perceive and confirm that it happened, and only get back to me once you have done so, or I guess maybe after a timeout where you don't think it worked. So in this case, get sensor. Now here feel room current. Not sure what those would mean, really. I mean current, or I don't know, some of those make sense, but not all the way exactly. Read the latest sensor snapshot aliased. Okay, so in their architecture, the microcontroller is just blasting updates every 10 seconds to the bridge. And then the client can request the current readings whenever they want. Sorry, I'm going to be highlighting a lot because I just kind of do it when I read this. The structure of this page is not great for it, but so those are the main two, like, data transmission things. Is microcontroller uploads every 10 seconds, client side can request whenever they want, and they'll just get the latest thing that came from this. Then there are output commands. So haptic, the vibration motor, draw a face, make a beep. Those get sent from the client to the bridge. And in order to get to the microcontroller, it is long polling this. So when the client is sending one of these commands, arguably maybe they should be a post instead of a get. I don't know. It's not really fetching anything. It's like asking for an action to take place. Not really posting data either, but I think it would make more sense. Anyway, the HTTP API they use doesn't matter. These are going to store a pending command in the queue, in the FIFO queue. And when the microcontroller hits this, requests this URL, it's going to get the latest one in the queue, the current one in the queue. And this is a long poll, which means this is actually just going to kind of like sit open, right? The microcontroller is going to send a request here. Even if the bridge doesn't have any data right now, if there's no commands pending, that request is just going to sit open until it times out, like several seconds later, a minute or two later, perhaps. And then as soon as it does time out, it's just going to send another request right back to there to start up another one and wait again for several minutes. When data does come in, then the server will finally respond to that request. So it will return whenever it gets data. So it's kind of like a real-time thing, but the client side is having to just send that request out and then wait and wait and wait and wait and wait and wait. And then eventually it will get a response, or it will finally time out, and then it will just restart a new request. So one thing that's definitely going to be different is that so my intention is to use only one feed, but maybe that's not the right idea. Maybe we should have two feeds. Let's think about that a little bit. So if we had one feed, then we can have the microcontroller pushing sensor readings to it on whatever schedule. We could theoretically have... Yeah, we really need two feeds, I think. We need one feed. We could think of it as one feed for sensor data and one feed for commands. But I'm not even sure that that's the right way to think of it either. I'm almost thinking really what we have is like TX and RX, right? We have one feed that is the microcontroller sending stuff to the client, and we have one feed that is the client sending stuff to the microcontroller. So when the client wants to, let's say, activate the vibration motor, it would add a new object into the, let's call it the command feed for now, the feed that goes from the client to the microcontroller. So it would create a command in that command feed. The microcontroller would be set up to listen. It would be subscribed to that command feed. Whenever that new object came in, it would execute the command. So turn the vibration motor on for however much it says. It'll come with arguments that say like, buzz twice or 5 seconds or whatever. It carries out the command. And then I guess it could send a response back on the other feed. And then oppositely for the sensor readings, if we had those separate feeds, that would just be by default, the microcontroller will post its readings to it every X amount of seconds. The client can always request it with an HTTP request from IO to get the latest one in that feed. The client side, if it wanted to, could also use MQTT to get a notification, essentially, whenever new data is available. Yeah, I think I like that idea. So instead of just one task queue feed, where's delete? Under disable? Where's delete? I think I've run into this. I think you have to come back here and then here, maybe? No. There it is. Okay. Click that. Task queue. Let's delete that. All right. Do I have enough for 2? I don't remember what it said before. I have exactly 2 left. I could delete some, but in fact, I actually have RX and TX. Maybe we should just use those. Maybe we'll just use those. Well, I'll rename. I'll give them better names actually, though. So let's say, let's call this. I am gonna give them names like client to MCU, client to microcontroller, and then microcontroller to client, MCU to client. Okay, let me make a group for these. How do I add them to the group? Oh. I do not, now that they're created. Feed info. Description key. Let's disable. Kind of looks like I don't now that they're created. Okay, so let's delete them again. Use enter. Okay, here we go. Now we have them in their own little group here, which is convenient. So each side can listen to their own one. So let's do, yeah, let's start pushing data into this. So I have a BMP 280 sensor. I'm gonna hook it up. I could show you, I guess. Try to show you. I have a great way to make it want to stay. This. Or upside down. Should I just flip the camera? It's gonna freak out my brain probably. Can I just flip the camera? I'm pretty sure that I can, but I don't know. I might not be able to do it while it's on? Sworn I found it before. I'm gonna try closing it for a second. It was the other camera. Huh. So weird. Oh. Okay. You gotta press the M key. Also, I figured out how to minimize this thanks to my wife. All right, so let's get that reading BMP 280. Ooh, I don't know if it's actually 280 or 28x or something. 2x? No, okay, looks like that went. So it's temperature and pressure. So let's see if I can do it off the top of my head. I don't know. And it should just be give it the I2C, and then we can maybe it wants this. Give it the I2C, and then we should just be able to get like dot temperature and dot pressure. And I think it should just work. All right, so here we're going to bring this back. Send a new message every 10 seconds is going to become actually set to 5 seconds though. Okay, that's not. No, don't do that, please. Okay, wow. Yeah, that's... I wish I could disable that somehow. One of the keys does that. I'm not sure which one. I haven't really experimented all the way, but one of the buttons on my keyboard does that. I really want it to. 10 seconds. We don't need a random value. We can get rid of this. We're not publishing to demo feed. We're publishing to MCU to client, right? Because we are the MCU here. We're sending it to the client. The value that we are going to publish is actually going to be called data. It's going to be an object, and it's going to contain the temperature. It is going to contain the pressure. Thank you very much, IDE. I'm pretty sure this doesn't have humidity. I could be wrong, though. It does. Not of humidity, but it says the word humidity once. Yeah. Has pressure and temperature only, but accidentally looks like humidity got copied from a different driver or something, is my guess. Okay, so temperature and pressure. Let's also add, what else? Let's add a little bit of, like, we want a little bit of metadata, basically. So we want to say that this is, well, so for one thing, we want to be able to deliver multiple messages at once, I think. Most of the time we won't, but we want to be able to. So this is actually going to be a list. Data is going to be a list of messages, and then each message is going to be an object. And for now, I am just going to say metadata type sensor reading, periodic sensor reading. I don't know if we need to be that specific, but okay. And then what we're publishing is json.dumps. Well, we don't need to do that here. Actually, we could just say data. But when we go here, we're going to go json.dumps data. Not going to go to demo feed. In fact, I need to change where it subscribed also. Well, actually, we don't want to subscribe to this one. We want to subscribe to the other one. We don't have JSON yet. Okay, so that should push temperature every 10 seconds. And pressure. For subscribing, we will subscribe to the other one. Client to MCU. So I think it converts those underscores to hyphens. It's a shame, because I kind of sort of mostly explicitly use underscores partially to avoid hyphens. Although I will say the main reason I kind of avoid hyphens is, well, one of them is Windows turning them into what I lovingly refer to as broken hyphens. M dashes, or whatever Outlook and other Microsoft products do. 102. Oh, interesting. It has Adafruit on the name of the class. That's atypical, I think. All right, there we go. So subscribe to that. It sent some data. We don't have anything here yet, but here we should have nothing also. Oh, wait, what? Speed limit reached. I thought it was on 10 of 10. I'm trying to create a new feed. Right, we should stop this because it's going to just keep going, by the way. And to create a new feed. So it's, I think maybe it's not finding the one that exists. Wish I could go to groups. No link for groups here. Oh. Groups add to the name, which I did not know. So basically it was trying to create those two. Does there create in this? Create? It must just do that automatically inside of the library, I guess. All right, so client to MCU, that's what we want to subscribe to here. Oh, that's got spaces. We don't want those. It's actually got a lot of spaces. I wish you could copy click this or something. Wait. Yeah, okay. So and then we publish to here. Yeah, that's the other thing about hyphens is if I double click this, the hyphens make a wall for the selectee bit, and underscores do not. If those, like here, I can double click it and it does the whole. So sort of a first world problem kind of a thing, but I do like underscores better for that reason. For those reasons. Okay, let's see if that goes. That's weird that there's no error here, but there is an error on this side. Kinda, to me. All right, there we go. There we go. Now we have data here. We got pressure, metadata stuff, temperature. Boom. Very good. Okay. For now, I don't really need 10 seconds. That's awfully fast. Maybe eventually we could put it back to that, but let's make a what do you want to call it? Interval. Interval equals. I'm gonna do for now like 30 seconds. Maybe we should call it periodic interval since I did periodic on the name of the reading there. I don't know. All right, that will slow it down. And theoretically, it should also receive messages. So if I go here and I go back and I go here and I make a new one, again, we do messages, a list with an object. We'll give it metadata, another object, type, command. So that is the metadata object. So then we'll also give it a, we will give it, I don't know, I guess a command key. Equals, show face, show happy face. It doesn't really matter if it's valid JSON just yet. Yeah, nice, we got it right there. So feed, client to MCU, received a new value, messages. We got one message. In that message, it has metadata type of command. It has a command of show the happy face. So when we receive that here, let's start doing more stuff with it. So instead of just printing it, let's go, well, let's start with JSON decoding it. I don't if we have indent or not. Yeah. I went with my gut. Huh. Is it already JSON'd? It might already be JSON'd. Like payload might already be a dictionary here. Like it might have already got JSON. Oh, wait. I don't want to dump. I want to load. Okay, here we go. Again. There we go. Okay. Now this, I mean, it's hard to tell because there's no separator or whatever, but like this is when it was a string here, and then this one, it is JSON parsed. It was correct syntax. Okay. Yeah. All right, so let's start building up this bit a little. So sure where I want this stuff exactly. Task queue is an empty list. I'm gonna make it shouty. But we should maybe call it, well, so it should either be a command queue or a message queue, or I guess we should have multiples. I mean, do we need a message queue exactly? We don't really need a message queue because we get a callback every time we get a message. We should loop over all the messages that we got in that list of messages, and we should sort them once we get them. So if they are a command, then they would create something for the task queue. If they are something else, then maybe they would do something else. Right now, command is really the only thing I have in mind that they could be, really, but yeah. Okay. So when we receive these, let's say here, loop over all the messages. So for message in, we should say data equals, I don't really need to print it twice anymore. I just wanted to make sure it parsed. So for message in data dot messages, if message so really we need if metadata in message and metadata type equals command. Now one question is, do we put the whole message in the task queue? Yeah, I think we would want to put the whole message in the task queue. So task queue dot append the message. Okay. And we also want a def handle task, which doesn't really need anything, and it is just going to handle the 0th index in the task queue, the first item in the task queue. So cur task message task queue pop 0. So we know what about it. I think we're gonna define the interface now to say if it's a command, then it's definitely gonna have a command key. I think we should have arguments also. But arguments should be optional, I think, because like sometimes you may not want to give it anything else. I mean, you could argue maybe that it should be show face and then the argument is happy. Yeah, in any case though, I think we definitely want one thing that's a command. I'm thinking string for now, and then one thing that's arguments, and that would be a list. And you could have multiple arguments. Or just one if you want, or 0 if you don't need them. So when we're handling the tasks, we're going to say, no, we already know that it's a command because we didn't put it in the task queue if it wasn't. So we don't need that. Cur task. So if arguments in cur task message, get the arguments. Get the command. And I think what we are going to do is just, we're going to make another function here, handle command, or maybe do command? Handle command? Do command? And arguments. Def do command. And arguments. If command equals happy face. Here we would draw a happy face on screen. Oh, happy face. We're just going to do that for now. At the bottom of this, we're going to have else, an unknown command. Unknown command. And alright, let's see if all that works. No. Oh, I never called any of this stuff. I never called handle task. So inside of here, while true, we should also do handle task. So for each loop here, it will check for MQTT stuff. It will handle the current like task in the queue. If it's been 10 seconds, then it'll send a new thing. Then it will loop and go again on all of those. One thing I don't know is if this blocks. I Well, no, this must not block, because otherwise we would not get... This would not have worked every 10 seconds because we didn't receive anything. Yeah, this must not block. Okay, so that should work, I think. Next out of range, 89. I do 1 instead of 0 or something? 89? Oh, right, if there's no tasks, then we can't do that. Yeah, I mean, that's the same. I don't know. I kind of don't. Kind of like this a little better, even though it does the same thing. It's just like makes the intention like more clear in my mind. Like, it should never be none. If it's none, that's a different problem. All right, there we go. All right, so we got our command. We got show happy face actually executed. Theoretically, if I did something else here, show sad face, then it will say unknown command. Yeah, okay, cool. Cool. So we have a queue of stuff that can build up. The client can send commands to the microcontroller. The microcontroller can send back data to the client or to the I/O feed, which the client can get from. Maybe we should... I think we should send an ACK. Once we get into the perception loop, then our ACK will contain, like, the proof that we perceived what we thought we did or whatever. But for now, I think even it would be good to go ahead and send back an ACK. And in fact, I think we should change up this object a little bit further. And honestly, I want a better way to make them than just copy pasting that and doing it again every time. Let's get a send command. AIO send command. Not very creative again with the name, but data. Actually, let's see here. So we have a choice here. So we have on our object, we have metadata, which is another object, and it contains that stuff. Then we have command, which would be a string. Theoretically, here we could have arguments, which would be a list. But truthfully, I want a UUID here as well. So the question, though, is should command be an object, basically, instead of command being a string which has a bunch of other strings alongside of it, or a bunch of other keys in the dictionary alongside of it that happen to go along with it? Should command actually just be an object with this stuff in it? Because the UUID, which I'm contemplating adding right now, I think really is the UUID of the command, not the UUID of the message. I'm kind of not really intending to put UUIDs on messages. But if the message is a command, I think it should come with a UUID. And I think the ACK of that command should include the UUID so that the client side can know that they can know what the ACK applies to specifically. So if they sent show happy face and they also sent another thing like beep the beeper at the same time, then they would want, theoretically they would want 2 ACKs, one for each of those commands, and the UUID would separate them. So I think I actually do kind of like this better. So command, I think, should be an object. I'm going to start breaking this up some. Should have a name, I guess, or... I mean, it could be... could just be command, I suppose. Oops. Okay. For sure. I mean, the other thing is maybe UUID could be inside metadata. It's kind of random in that case though, because this is like the message metadata, not the command metadata again. So it's like, I think here makes the most sense. Yeah. All right, so this is like a command template. Oh, you know what? I totally did not have the YouTube chat open, my bad. I mean, I had it open, but couldn't, had it behind some stuff, so sorry about that. What's up, Gordy G, by the way? I'm not sure. These aren't timestamped either, so this might have been from a while ago. So my apologies again. So it says, can these things talk to each other? I'm not sure what I would have been showing at the time, but the intention will be for the microcontroller to be able to talk to the client, which in my case, the intention for the client is an LLM agent running on a computer. But realistically, this part of the system is more general than that. This could be used for other sort of IoT things, even if there's no LLM agent involved. This still kind of gives you this bridge of microcontroller to some other client program. And they'll be able to talk back and forth to each other. Or is it just one interacting with a static environment? So it will be both of them being able to interact with each other. And then, I don't know if you caught the very beginning, but the key hook, the key sort of thing from this paper is this like self-perception loop. So I have not even started it, yet at all on the actual circuit or the code. But eventually we'll have, for instance, like a piezo buzzer, and then we'll also have a speaker right next to it so that it can make the piezo buzzer buzz and it can read the speaker at the same time, and therefore like sort of know that the piezo buzzer worked. It can measure the effect of the piezo buzzer. And so when the client asks the microcontroller or commands the microcontroller to say, hey, please buzz the piezo buzzer, it can, as an additional argument, it can say, and send me back the proof that it worked. And so then in that case, the MCU, the microcontroller, will buzz the piezo, it will read the speaker, and then it will send back an ACK that contains the readings from the speaker that show that the decibels are, were higher over the preceding 1 second or whatever when the buzzer was running. So that's kind of the core idea, is building this bridge between the microcontroller and other client programs and having the microcontroller be able to output things into the world with a self-perception loop where it can measure the effect of that output to kind of confirm. They say in the paper that it landed, but really just confirm that it, that it did what it thinks it did, right? Or that it did what it tried to, is the idea. Okay. All right, so what I want though is Adafruit IO examples HTTP, and I just want like to send some data and data. One thing is requests. I think we could use actual requests maybe for this, hopefully. Actually, maybe we don't. Maybe we could even not do that. So, cell context. I wonder if we could actually just skip all of this and do actual requests. But that's a session? It's not session. Not sure if that's gonna work. This does not have the keys either. Should not quite as conveniently just grab out of okay, here's what we're gonna do. Import OS. I'm gonna do this the same as this, but it will have to be done, have to be set differently. IO environment.shell. Export this equals something. Export this equals something. Sure if I need quotes. Do a lot of bash scripting directly, very much, truthfully. One more second, actually. Let me make sure. Whoop. Okay, yeah. All right, there we go. Very good. Okay, those are there in my environment now so that I can get them in the script. Again, ideally without showing them. I don't know if this is going to work with requests. This is a session. Maybe we need to create a session. I'm not sure. I don't really need to get the temperature feed, and I definitely don't want to create a feed because I already have all the ones I can have. I want to send some data. Okay, we need to get the feed still, even if we don't want data from it. Interesting. Is the key on this page? Maybe under the key, though, if it is. Oh, no, and it's not. It's too big now. Can't see it. Copy it from the other one, I guess. This is going to be the one we subscribe to. Client to MCU. Get that feed. If there's a request error, honestly, just raise it. Yeah, just raise it. We don't want to be creating any feeds. We just want to bail if there's an error. So get the feed. We're not going to do a random value, sending, we would want to fill in the template some. So command template, command name, show happy face. Yeah, that one has no arguments, so we don't actually need that, but UUID we want. I don't know how to make one. I don't know the correct syntax to make one off the top of my head. I'm gonna create it from bytes though. I want to create a, I guess a random one. UID. Where's v4? V4 one? UID v4. UID 4. Maybe we would want to copy it? I mean, we're only sending it once anyway, though, right? This is like a one-shot script, so whatever, we'll fill it in. UID, sending, command template, send, picture feed.key. Oh, that's interesting. Okay, we're actually going to call this client to MCU feed. Random value, it's not going to be random value, it's going to be command template, but I guess we want to JSON dumps. Data sent, retrieving, we don't really need to retrieve. Mostly just want to send it. And on the microcontroller side, we need to fix up this part a little bit, so the command here is actually going to be command name. The arguments would actually be command. And we know this has a command because it wouldn't have ended up in the task queue if it didn't. So I think it's safe to assume that command exists. We check if arguments exist, because that's optional. Could be not having any. Command name we know is there. I don't even know if we need that, honestly. We could just give it the whole command object at this point. This could go inside of here now, honestly. I think this just could be command object. Command equals command object. It's actually name. Arguments we would handle inside of here. So in here, if it needed arguments, then it would handle them there. This is command. If arguments in command object command arguments equals command arguments. Okay, UUID happy face. So I think what I want to do is send ACK, and we give it the command object. Def send ACK, and that is basically going to do something like this. but it's going to be metadata type ACK. And it's going to be just to send the whole command back, honestly. We'll have the UUID and everything else. So one thing is, though, one of the other things they mention in the architecture of this system that I am sort of building an analogy to is always sending back the current data as a sort of side channel response, they call it. I don't recall perfectly where they express that, but I know that I read it in here somewhere. I don't know. I think, though, well, no, I don't know. For now, I'm not gonna do it. I'll have to read through their thing again. I'm thinking maybe there was something in there. I'm pretty sure there was something in there about always sending back the current state, essentially, with every sort of response that comes from the microcontroller. Like, always send the current state. That way the client side always has the current state of all the sensors. Yeah. Actually, let's do that. Let's go ahead and do that. But let's set it up for future stuff as well here. So let's say get sensor readings. And what I'm going to do is, this is actually going to be metadata type periodic sensor reading data get sensor readings. Get sensor readings is going to return this as an object that's formatted in any sort of sane fashion. Actually, I'm going to call it sensor data. Might even want to call this periodic sensor data. And then on the ACK, I'm just going to throw on sensor data, get sensor readings. So when we send this ACK, we're acknowledging that we got this command and that we carried it out. Not with the proof yet. This is not with the perception loop at this point, but just acknowledging that we ran the code that supposedly did the command. So we're acknowledging that. We're sending back the command, which is going to have the UUID in it. So the client side's going to know which thing we're acknowledging. And then it will also, just as a bonus, get the current sensor readings as well. Yeah. I like that. Okay, so let's run this. And then let's try running this, which should send the happy face command with a UUID. Theoretically, if everything is set up, we should get back the acknowledgement there. Maybe we would want to send an acknowledgement in this case as well, but like with an error message. All right, we'll cross that bridge when we get to it. So this is wrong though. Do command does no longer take arguments because they're inside the object. And actually command should not be command name, it should be the object. Okay. Yeah. EMV is not defined. All right, I gotta run to the restroom. Excuse me, real fast. So I'll be right back. Okay, here we go. Does it work this time? Oh, IO HTTP is not defined. Which is fair, because I did not port it. I actually need the error one anymore. Later for IO. Do pip install Adafruit CircuitPython Adafruit IO. Found. Name does not exist. Hmm. Yeah. Do you know what the problem is? Is that when I run this, by right-clicking it and choosing run here, it's like spawning a new like shell to run inside of, basically. It doesn't have my environment variables, which means that it doesn't have my username and token, which are coming from environment variables. We could go to configuration here and I could add them and they could work, but I can also just do it this way, I'm pretty sure. And they will have my environment variables. In fact, we made it to a different spot, so it definitely got better. So it says man template error command. It should really be payload template. It's actually more than just a command, right? It's the list of messages. Inside the messages, there's one. messages 0. UUID is not defined. It's weird that none of those were red. Why were none of those red? Expected string got UUID instead. Turn it into a string. Man template. It's not even really a template, honestly. We should just call it payload at this point, right? I mean, I suppose it starts life as a template, but we fill it in. Why did this not rename? What is this IDE doing? I don't know. I think it's because it's yellow. That means like not tracked or something, making it not do a bunch of the helpful stuff it normally does. All right, let's try again. JSON is not. Yeah, that's so weird. Why like? Let's see, miss anything? Made it all the way to here. I mean, we should be getting pretty close. I think data sent. Okay, very good. No arguments. We have a UUID. We can check here. Well, we could check here actually if we received it. Yeah, looks like we did. So client to MCU, we received the new value here. The command was show happy face, and then we are publishing an ACK to this command. Oh, we only sent back the name, not the. We only sent back the name, not the object. We want to send back the whole object in the ACK. Would be fun to have commands like smile, frown, look, listen, speak, sing, and smell. One step closer to personification. Yeah, I agree. It's like once we get this going, I would definitely like different faces to represent different sort of like states. Could imagine it being like happy face when it's done and everything worked, sad face if there was an error, maybe a thinking face or something sort of neutralish if it's like doing its thing or whatever, you know. Yeah, the idea like in the direction I'm headed is like to give that LLM sort of the ability to output into the world and with this perception loop to verify that the output happened in some cases, the buzzer and the lights and the speaker. The screen's a bit different. Maybe eventually we have a camera or something as like an add-on. I don't know if that's gonna make the cut for the first thing, but theoretically you could do it with a camera in the screen as well, right? All right, so why did we only ACK the why did we only ACK yeah, okay. This should be command object. All right, that reset. Let's run this again. And yeah, okay, so there's the ACK command. This time has the stuff. So it's UUID, arguments, name, all there. All that's in. All right, so we got the command to show the happy face. We did the action for it. We sent the acknowledgement along with the current data. So now from the client side, the way we would do this is we would have the client side subscribe to that feed that the microcontroller sends to the MCU2 client feed. The client would subscribe to that. Then it would send its message with the command. Then it would wait a specified amount of time to get the acknowledgement back. And if it didn't receive the acknowledgement in that time, then it would like, you know, time out or whatever. It would raise, it would know that it didn't work. If it does receive the ACK in that time, then it will give that data back to the LLM. The LLM could do something else with it. So it can be like, you know, hey, I just buzzed the thing, you should have heard it, I heard it, or whatever. Okay. Let's make it actually do the face. That seems like a nice like 15 minutes or so. I think we could knock that out. So in the paper they have they have this face going. I don't know if I want to keep that for the long term, but it seems like as good a spot as any to start things off. Now, one question is, well, multiple questions rolled into one is how to draw it. One big bitmap works, but it's kind of inefficient if we want to change it. 3 small bitmaps also could work. Then we could maybe use rotozoom and some stuff to manipulate them to make different faces out of the same components. No bitmap files at all. Instead, draw the bitmaps from code. That's an option. Even like vector IO. Well, I don't think there's arcs in vector IO though. Okay. Let's keep it simple for now. Let's keep it simple for now and just go full screen bitmap. How big is the screen on this thing? I don't actually know. I think it's maybe 135 by something. Let's say reverse TFT. It's 3. This is what? 240 by 135. Let's say GIMP. Is it 240? 40. It's very wide. 240, 135. Let's do background black. Probably a good size. I'm going to show grid. That doesn't work because the grid's black, I think. Yeah. Somewhere there's... Did not change configure grid. We need to do configure grid, not the other one. Okay, and then I want like well, I can't split it in half, can I? It's a shame. So I guess we'll do as close as we can get. So half of 134 is what? 50, 65, 2, 167? 7? 7 times 2? 34. So unlock horizontal 67. Vertical, let's just make it the whole thing. So 240. Oh, I did that wrong. I did that wrong. There should be 120, so we can cut it in half. 120. Vertical is the whole thing, 135. And now the problem is, though, it's going to be offset by 1. So honestly, this whole thing is kind of like, might have just not been worth it, truthfully. No. Yeah, because we're back to 120, so that should be fine, actually. Put that back. Okay. Yeah, okay. Alright, so I don't need... We're not going to use the whole thing here. I just kind of wanted half so that I make the eyes sort of... similarly sized and positioned, basically. Is that too much of a... I think I did that right. Could have flipped it, I guess. How much space is actually here? So this is... One, two, three, 4, 5, 6. Two. Actually, let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 total. So 1, 2, 3, 4, 5, 6, 7, 10, 11, and then this goes next to that, so we need to scoot over by 1. And don't really want these things here. What's up, Yano? Nice to see you today, my friend. Okay, so there's the eyes. Let's merge those down. Oh yeah, usually I use the select tool like this to count. I don't know why I did the pixels the other way, honestly. That was kind of silly. So then for this, I'll just do, for the mouth, like, maybe new layer. Like here. So we go 1 on the left side, 1 on the right side. Actually, I can grow this by 1 each time by doing this. Although, do we want it like that? I think I need to be lower, actually. Maybe I should actually just do one side and then mirror it. I can do that. Okay. No artist, but it's a smiling face. It looks pretty happy to me. Okay, hold on. Let's do mode indexed. We don't have transparency, so the order doesn't really matter. All right, let's just do sort of a basic display setup. Main group, display, group. Tile grid. Now we can't create the tile grid until we have bitmap. You can change both bitmaps and pixel shaders? I'm not sure. Basically, I don't think we want to create the tile grid yet. So, because what I'm going to do is when we have do command and the command is happy face, here's where I want to create the tile grid. We need the bitmap first. On disk bitmap, ODB. Bitmap is happy face. Bitmap, and then that has pixel shader. So then tile grid ODB. That's wrong. I want ODB.pixel shader. Then main group .append PG. And I guess what we'll do is main group dot actually a length of in group greater than 0 in group pop. So remove everything, then make the tile grid and put it in. Theoretically, it should show. Well, we need to still show the group though. Here, so display. That's the wrong way. Supervisor, runtime, display. There's RuPy selfie bot. Animation sounds and faces. Oh yeah, that's cute. Reminds me of this, I can't do copy the links like this or something. It reminds me of a video I was watching on YouTube. There's actually been a couple installments now of this like BMO bot. Oh, are these sized for this? Oh, they're huge, but we could cut them down. Oh, they're pretty close actually. So it's a little bit too tall, but because it's not off by much, and because there's nothing at the top and bottom, totally could actually just use those. That's way better, even though I spent all this time with my amazing... Well, actually, let me do mine once. We might as well show it once, but I am totally just going to switch to this, because that's obviously way nicer. Let me do mine real fast, though. So supervisor... display... root group, main group. Yeah, thanks for the link, by the way, Secret. That's really nice. Let's see. Funny you're working with Adafruit.io today. Just spent the last few days on a proof of concept build that uses WASM binary talk with sensors, simulated a reel, essentially using whippersnapper protocol. Nice. Yeah, Adafruit.io, it's convenient for experimentation. Quickly store some data online somewhere and push to it and notify from it. Wrong terminal. Okay. Yeah, theoretically that should work. So the display's blank now, which is good. Like shows that it set the root group on it. Nice. I should have maybe nice. There we go. Okay. Let's try this instead. IFTT. If then if is it if this then that, I think. Squinchy. I need to get down to 135, so I need to cut 9 pixels. So we have to be different on the top and bottom. So 9, it would be 5 and 4. Like we maybe have slightly more room at the top, so I guess I'll do the 5 on the top. Maybe even 6. Did I say 9? Does that not feel like 35, 5 to 5 and 4, 9 more pixels. Six. Does that not feel like this is at 9? How can there still be pixels here? I don't really trust this now. Six is fine though, I think. That's weird that it came to 2 different sizes, basically. This one. Squinched face. Not sure what we're gonna use that one for. Looks unhappy, I would say. Looks like it got bonked on the head or something. Work. Squinched face one. 0, 6, 6, 40, 35. It's not like the copy first time for some reason. Honestly, these should be like face thing instead of the other way around, so they all get sorted together. Face sleep, face happy. Keep the 1 on it just as a second. Uh-oh. Wait, what? Oh god. I think I wrecked it. Yeah, that should be not 1. Face happy 1. And face squinched. So now they're all in the alphabetically together. So here, you command happy face, face happy 1. Failed. Maybe I didn't wait long enough. P1. H-A-P-Y, I didn't spell it right. There we go. Kind of blew out the camera, but... Oh. Very bright. So here it looks like light blue. But on that display, it looks like white. I mean, it's blown out. I don't know if it will focus. Backwards is messing with my brain. Yeah. In any case, it did it. And it is cute, but it's very bright. I think I will try to make them a darker bluish shade. But it did it. So we made it to there. All right. I do think I'm probably going to wrap it up for now there. So I will say thanks to everyone for watching along. I will be back on Tuesday at the same time I started today, 10 a.m. Central Time on Tuesday over on the Adafruit channel. I will be deep diving, showing what I am working on. As far as I know, Scott's playing deep dive on Friday, so therefore, as far as I know, I should be back next Saturday. Same time, same place here on my channel, 10 a.m. Central Time on the 9th. I think I'll be back next week. If I'm not, then I apologize. But I do hope you all have a good rest of your day, a good weekend, and all that stuff. So long. Thanks for hanging out. I will see you later.